Alright, I'm going to take you through this study guide so that you have an idea of what we're actually going to be doing tomorrow on the test. This has just a little bit more of the conceptual stuff that will be on the test. So first thing we're going to talk about taste for acids and bases. So, with an acid, they taste sour. With a base, they taste bitter. You should also know that bases feel slippery. So something like soap is a base, and that is why it feels slippery. Weak bases always feel slippery when you touch them. Conductivity refers to whether or not it's an electrolyte. So, if it is a strong base or a strong acid, it is a strong electrolyte. If it is a weak acid, it is a weak electrolyte. That means it's a good conductor. A weak electrolyte means it's a bad conductor. Strong acids are strong electrolytes, weak acids are weak electrolytes. The same is true for bases. A strong base is a strong electrolyte. A weak base is a weak electrolyte, making them good and bad conductors, respectively. Now we're going to talk about products of reactions. When an acid interacts with a base, they form water and a salt. You guys know that from our neutralization work. When an acid hits phenolphthalein, what we use in our titrations, it's clear. When an acid hits litmus paper, it's red. And when acids interact with active metals, they form hydrogen gas. Now we'll fill out the base column. When bases interact with acids, again, they form water and a salt. You know that from our neutralization work. When bases interact with phenolphthalein, they form pink. Think about it as your burette was filled with base, and as you added drops from your burette, it turned pink and disappeared until it finally turned pink and stayed pink, indicating that you had base in the mixture. When bases hit litmus paper, they turn blue, and when bases react with active metals, there's no real reaction. Now, for acids, the ions that are produced are H+ ions, but remember, when an H+ ion interacts with water, it actually forms H3O+, which is called hydronium. That's an important thing to remember. Anytime you see pH, it could really just be PH3O+. The ion that's produced when bases hit water is OH-. That ion is called hydroxide. Alright, now let's write the name and chemical formula of some of these things. So the acid found in your stomach is hydrochloric acid. So HCl is hydrochloric acid. The acid found in vinegar is HCH3COO. You should recognize CH3COO- as one of your polyatomic ions. It's acetate. When acetate becomes an acid, you ate the whole cake, so you get sick, so it becomes acetic acid. And acetic acid is what's in vinegar. Alright, next side. Okay, now we're going to talk a little bit about pH, H+ ion concentration, and OH- ion concentration. So if it's acidic, the pH is below 7. That means the H+ ion concentration is 10 to the -7, or down in numbers, meaning like 10 to the -6, 10 to the -2. Those are actually larger numbers, but the exponent goes down to show you that the number is getting larger. The OH- is just the opposite. It's above 10 to the -7, so 10 to the -14. Any number in between 10 to the -7 and 10 to the -14 for an OH- means that it's actually acidic. If it's neutral, it's 7, and both of these are 10 to the -7. A neutral compound will always have an ion concentration of 10 to the -7, an H+ ion and an OH- ion concentration. Basic is just the opposite of acid. Any number larger than 7 on the pH scale means it's basic. Any H+ ion concentration that has a large exponent, an exponent larger than 7, means that it's a really small number, so it's basic. If the exponent is smaller than 7, it means it's a larger number, so it would be basic if the OH- concentration is 10 to the -7 or below. We're not going to worry about that. You guys can solve those problems. Explain why water has a pH of 7. Include a balanced chemical equation. Well, the balanced chemical equation we'll use is the auto-ionization of water. Remember that water will spontaneously split up and form H3O+ and OH-. You need 2 water molecules to do that. But this is why water is neutral, because the H3O plus is always canceled out by an OH minus, and they would just form two water molecules. So that will always keep them neutral. Finally, we've got a neutralization reaction. HCl plus CaOH2, because it says hydrochloric acid with calcium hydroxide. How many moles of hydrochloric acid are needed to neutralize 3 moles of calcium hydroxide? So first we need a balanced neutralization reaction. All of the leading H's and all the trailing OH's make water. Then finally, we need to figure out what salt we have. Well, we have Ca and Cl left over. We need to figure out Cl's charge. Hydrogen is always plus 1, since it's bonded to just one hydrogen. Cl must be minus 1. So we put a minus 1 by Cl. Now we need to figure out calcium's charge. Calcium is bonded to 2 hydroxides. Hydroxide is always a minus 1, so 2 times minus 1 is minus 2, so calcium must be plus 2 to cancel it out. So on this side we put calcium as plus 2. Calcium is plus 2 and Cl is minus 1, we will need 2 Cl's to cancel that out. Once we've canceled it out and made a neutral salt, we can no longer worry about the charges, we just have CaCl2 and balance it. 1 Ca, 1 Ca, 2 Cl's, 1 Cl, so we'll need a 2 out front. And now we have 2 hydrogens plus 2 more hydrogens is 4 hydrogens. The way we make this 4 hydrogens is by multiplying by 2. These will both stay 1. Okay, now I'm going to work the mole problem right up here. It says that I have 3 moles of calcium hydroxide. How many moles of hydrochloric acid are needed to neutralize it? So I'll start off with 3 moles of calcium chloride. Oh, excuse me, calcium hydroxide. It'll be a one-step dimensional analysis problem because I'm going from moles to moles. I'll have moles of CaOH2 on the bottom, and we want to go to moles of hydrochloric acid, so I'll have moles of HCl on top. The way we figure out what numbers go in there is from the balanced chemical equation. We have a 2 in front of HCl, so we put a 2 in front of HCl. We have a 1 in front of calcium hydroxide, so I put a 1 in front of calcium hydroxide. And I end up with 3 times 2, which is 6 moles of HCl for a final answer. Alright, we'll go over this before class tomorrow. If you have any questions, send me an email. Otherwise, good luck studying.